Okay, so for the Tarzan problem, okay, I had some of you guys ask me about the Tarzan problem, so I'm going to kind of set it up real quick, and then let's talk about it, okay? Kira, what are your numbers?
The total math is 155. Divine is 5.6 meters.
Okay,
They have an angle of 35.7.
okay,
Jane's mass is 47 kilograms.
47,
47.
okay. And anything else?
Acceleration of gravity, 9.81.
9.81. And what's the question asked for?
What is the maximum height at which Tarzan can land on a branch after his swing continues?
The maximum height that Tarzan can land on the bridge after the swing. Okay, so let's talk about this. So you have Tarzan and Jane on the vine, okay? And as they are swinging on this vine, they're going back and forth, right?
Yeah.
Not really back and forth, but what you got the problem is, they start here, they swing down, and then Jane lets go, right?
Yeah.
Jane lets go, and Tarzan keeps swinging upward, right?
Yeah.
So what we need to do is we need to figure out how high Tarzan's going to go. What type of energy do Tarzan and Jane have over here?
Potential.
Potential. They have potential. The question gives you a hint, and it says treat it like they're two separate energies. Because when it gets down to here, when Tarzan and Jane get down to the bottom, Jane lets go. What happens with her energy?
Goes with it.
It goes with her. She has speed, and she goes flying off down to the ground because Tarzan, the jerk, just dumped her. Right? And so he lets go of her, and she goes flying off into some shrubs and hits a snake or something. Okay? So, where is Tarzan's energy then?
Still with them.
It's still with him. How much of his?
All of it.
All of it. So whatever he had PE is now his KE. Okay, neglecting friction, which it tells us to neglect. How much of his KE becomes PE when he gets back up?
All of it.
All of it. So his height when he gets back up is going to be exactly the same height that he started. Does this make sense? Okay, so we have his 1/2 mv squared over here, his mgh here, and it's back to the original mgh right there. Okay, so then we need to figure out, if we can figure out the mgh here, then we have his potential energy, right? Which is mass, we could easily do, because we have mass of both of them,
It's
mass of Jane, which is going to be the difference between the two.
78.
It's 78. So the mass of Tarzan works out to be 78, because we did 125 minus 47, okay? We have gravity. All we need is height for the potential energy, right?
Yeah.
Well, isn't that what we need in this question in the first place, is just the height
Yeah.
that he's going to end up at? So we don't even have to worry about any of this other stuff with the energy. So all we have to do is say, what's that height going to be? Well, that height, if we take a look at that situation right there, that height is going to be the length of this vine minus this side right here. Okay? That side. Not signed, side. Everybody follow me? Because if I were to take this length of the vine, it would be all the way down here, right? Where my dashed line is. Everybody following? Okay? So then, I need to figure out this side. Where's my angle in reference to?
The potential energy. Like that.
No, it says in the question, it
Oh,
says, your angle with reference to...
The horizontal.
The horizontal. So right there. which means where's my complementary, or not my complementary, where's my same angle? My congruent angle? Right down here, right?
Yeah,
So what side is this?
opposite.
Opposite of the angle. So what do I use there with that opposite side and an angle?
Side.
Sine. So then if I take, and I take the length of the vine minus that side, which is going to be equal to the length times sine of the angle. And that's going to give me my height. So our 5.6 meters minus 5.6 times sine of 35.7. And that gives me my height. And what do you get here? 2.33. And what's the unit?
Meters.
Meters. So that's how high he ends back up. Does that make sense?
How did you get the mass? It was 125 minus what?
Mass of the total minus the mass of Jane. This was the total of them together. And so, yeah, I'll put kilograms up there. So 125 minus 47. Okay. All right. That's the Tarzan problem.